What is going on, my programming stallions? It's Zach here, back with another GameMaker tutorial, and today is the kickoff of our online multiplayer game series. In this series, we are going to be creating a top-down shooter game with full multiplayer functionality. We're going to be going through a lot of parts, but I want to lengthen these videos as well to really nail down these concepts that we're creating, because this is going to be an advanced tutorial. This is not for beginners. If you're new to GameMaker, I would recommend watching some of my other videos first and getting a real hold on it, because you will not understand anything. And really, what I want to stress in this series is for you guys to understand what we're doing and what's going on rather than copying the code. So we're going to be creating a lot of stuff. We're going to be looking into a lot of stuff that I really haven't found anywhere on YouTube, which is obviously a server client connection, which will be global. So if you want to port forward your IP and host a server, you can do that. And so anywhere around the world, you can really play this with people. We're going to be looking into, obviously, a shooting system. I want to look into health bar systems, game rounds, game lobbies, an account system in the game, statistics tracking. I want to visit lag compensation, because that's a big one. And we're really going to do a lot of the stuff that you would need to actually create a multiplayer game that's very stable. So even things like reconnecting on a connection loss, motion interpolation, so that we can actually smooth everything out on the client side and really make it look like a very polished, very nicely fitted 2D multiplayer game. So without further ado, let's go ahead and start. So there's a couple things we need to know about when creating a multiplayer game. First off, that's the different connection types. There's TCP and UDP. So those are the two very basic networks that we can use, and this is something you're going to have to decide what you want to use. In this game, we're going to be using TCP. Now the difference is a TCP server waits for packets to be received before sending the next one. So it makes sure if this client's sending a message to the other client, it's making sure that that client is receiving all of the data that it's been sent, and it's waiting. It's sort of in line of gathering that data one by one in order. A UDP server just sends all the packets without waiting in whatever order, right? So it's the problem with that is you can have some data being lost, and it's not 100% that it's actually getting received by the other client. Alright, so the perk of a UDP server, though, is that it's very fast. So a lot of these games, like the bigger games like Call of Duty, they actually use a mixture of both. They use TCP and UDP just for different things that they want to go ahead and do. If they don't really care about some data getting lost, then they can use it that. But if you want sort of like a chat system or something, you can't have data loss in between chat messages. It just won't happen. Alright, so like I said, we're gonna go ahead and create a TCP server game here. So let's go ahead and begin. I'm gonna go ahead and create a script right off the bat, and I'm gonna name it server create. Whoops. Alright, server create. And every server is going to need a port, an IP address, and so on. But since this is just the server, we just need a port that server is going to run on. So we're going to put in the arguments the port. So port equals argument 0. If you're unsure what an actual port is, that's basically if you have an IP address. Let's say, just for example, there's not, but let's say there's 100 ports on that IP address. So it's just sort of like different channels. So if you want to be synced into like the 5th port, that would be different and send different data from the 6th port to the 5th port. So you can't actually cross the ports. It's just on one single port. It's kind of like tuning in on a radio station. You got to just tune in on that one, and you only receive that data from the signal of the radio. Alright, so then let's go ahead and say network create server raw, and the type, we're going to say network socket TCP, because we're using the TCP. our port is going to be our port, and our max clients, this is however many clients can actually be in your game. We'll just say 20 for now. Alright, so pretty simple. The reason why, now if you take out this raw, it'll still work, but the reason why we're going to use raw is because if we don't use raw, the actual network create server functions are a little bit different. So the network create server has more GameMaker specific code, and it's just like another layer of TCP code on top of it. If we do _raw, this will actually allow us, if we wanted to in the future, to create a server on C#, C++, whatever other language we want to build a server in, just out of pure speed. It's a lot faster to do that. Then we can do that easily, and we won't have to go back and change this to raw anymore. So it works exactly the same, and you'll have no problems creating a server with GameMaker. But just in case you want to do something like that, I would recommend that you use the raw functions, which we will be using the entire time. Alright, and if we go ahead and look at our network create server, you can see that if our value is less than 0, then the connection will fail, right? So if we go ahead and if we go ahead and create another variable server equals 0, and then we set server to this, then we can say if server is less than 0, then we'll show an error. Could not create server. And here we'll say true for abort. So just sort of like a fail-safe thing. And then we're going to go ahead and return the server. Alright, so this is pretty basic code right now. You should be understanding it. Yeah. So let's go ahead and create an object, and we'll name it oServer. And in the create event, we'll just call that script. So we'll say server equals server create at the port of 9000. Just make it easy. Pretty simple. So now what we're going to do is we're going to go into an event, and we're going to click our asynchronous event and go to networking. And we'll put in some code here. So if you're new to multiplayer, you probably have never used this event before, and that's okay. The networking event gets called when something happens with the network. You know, if there's somebody connecting to the network, if there's a message from client to client happening, it gets called in this event. If somebody is disconnecting from the server, it gets called. So anything that happens with our networking server, this event will be called. Alright, so pretty simple. To go ahead and vary the type of message that we're being sent, we're going to use our async load functions, which will tell us if we're getting a data type, if we're getting a connecting signal, if we're getting a disconnecting, and all that. So I'm going to make a switch statement, and I'm going to say async underscore load, and here I'm going to say question mark type, just like that, and that's because this is part of a DS map. So if we go to async load in our networking event here, as you can see, we have all of our different constant types that we can have. So we can have network type connect, disconnect, data, and our non-blocking connect, which we won't actually use. Well, we will use it, but you can just think of it as the same thing as our connecting. Okay, so again, pretty simple. Yeah, so let's go ahead and begin with that. So in our switch statement, we're just going to go ahead and use those different types that I just showed you. So we're going to say case network type connect, case network type non-blocking connect, and we'll break it, and we'll do case network type data, and we'll do case network type disconnect. We'll break that as well. Alright, so all of these, so this will be loaded when we're sending some sort of data. This is disconnecting and this is connecting. It should be pretty simple. So here we're going to put in functions that we haven't actually yet created. So I'm going to say server handle connect, and here I'm going to want to put in my socket ID. So async load question mark socket. In our network data, we're going to say server handle message async load question mark ID. And we're actually going to want two because we're going to want to use something called a buffer. Now, I'm going to explain the sockets, I'm going to explain the buffers. Just let me finish putting this in right now. So I'm going to say async load. We're going to call it the type of buffer. And then down here, we're going to say server handle disconnect async load, and this is going to be socket again. Alright. So every time a client connects, it gets its own socket number. It gets its basically it's an ID, and we can pass this socket ID to the server to kind of keep track of who is who in the server. So just automatically every time you connect, it gets a socket ID. Now for the buffer, the actual buffer is how we are going to send data. It's basically just a stream of bytes. We will provide meaning to those bytes later on by passing through X values, Y values for positioning purposes, maybe a username, all sorts of stuff. We're going to be passing through these buffers. So we're going to need, every time we want to handle a message, we're going to need the ID of the client, and we're going to need the buffer, which is basically the data we're sending. Okay, so let's go ahead and create these scripts. So I'm going to say server handle connect, server handle message, and server handle disconnect. So here, say server handle connect. We're going to put in our socket ID as the argument. Our handle message, we're going to say server handle message socket underscore ID, and our buffer. And then here, server handle disconnect, and we're going to put in our socket ID again. So let's go ahead and go over to Paint. And before I go any further in, let's explain what an actual server and client does. So here we have our server. Let me move that over here actually. And this server is basically the central point for all of the data. So if we have, let's say, a client right here that connects to the server now takes in that to account. Let's make them right here. That's sort of like the brain, so he knows that, all right, hey, here's a client we have connected. And what he also does when that client connects is this server pops out back at the client a socket ID, which is what we did. And this is how the server knows that client from, let's say, another client that connects. And he pops in there, we create another client. So now the server down here says, oh, there's two clients in here. This server pops out another socket ID to the client. So now, how does this client send a message to this client? So it's kind of cool to think that on each client side, there's really not, that actual client is not actually in the game. It's all ran through the server. So in other words, if we move our character, here's our game, if we move our character from here to here, it's going to send, let me use a different color, it's going to send that data of our X and Y to the server, right? That server is going to say, okay, the X and Y positions are moving. It just called, since we're moving, we're sending data, and it called that networking event. So that is going to push out the data to this client. And on this screen here, what we actually have going on is, if let's say this is our main client, this guy here, and our other client all the way over here with a different socket ID is this guy here. On our actual client's game, we're going to create an object called other client or something like that. And this is going to be an actual physical object in our game that its job is to do nothing but copy what our client all the way over here, which could be all the way on the other side of the world, is doing. So this client sends the X and Y coordinates to the server then sends it to our client, and that client code then says, hey, this other object in the game, we're getting data that says that you moved over here. So I'm going to go ahead and do that. That's basically what a server client system is. All right. So right now what we're doing is we're creating the server to take in those messages and to be able to set everything up. So on our connect, disconnect, we're going to want to give client IDs. We're going to want to do all that fun stuff. So yeah, let's go ahead and keep on going. So in our server handle connect, we're going to create a variable called socket ID, and this is going to be argument 0. And here we're going to say L equals instance create 00 O server client. And basically we're going to create this object O server client, and this is all server side. So basically we take this server client and it runs on the server. So we need an actual object in the game to represent each other instance of a client that actually exists and on their side, but it has to. So if you connect into a game, the server has to create its own object called server client, which basically keeps track of it. All right. So here I'm going to say L.socketID equals socket ID, and here I'm going to say L.clientID equals. And here, what we want to do is create client IDs. So our socket ID is good for identification, but it's a random number. So the ID can be from 3 to 7,000 to 37,320, right? So it's really abstract, and it's not really going to work for an identification system, because we can't just, if we wanted to do a for loop through all of the socket IDs, we really couldn't, because we don't know what those numbers are. So we need to create something more efficient, like a client ID system, every time a client connects. So if we go to our server create, what we're going to do is we're going to say client ID underscore counter equals 0. And in our server handle connect, we're just going to say client ID equals client ID counter plus plus. So what this does is it will set a variable of our client ID on the server client to equal what our client ID is, and then after it equals that, this statement here with the plus plus just increments it by 1. So next time a client connects, it'll be the client ID will equal 1, then 2, then 3, then 4, and so on. All right, so after that, technically, technically this could be bad, because if our client ID counter is greater than what an actual integer value can hold, which is like 65,000 something, then we're gonna get an error. So if there's 65,000 people that connect, and one more connects after that, an integer can't actually go that high, so we just need to create something that will loop it back in case it gets too high. So I'll say if client ID counter is greater than or equal to 65,000, then client ID counter equals 0. So it just loops it back. Now, the only way this would be bad, and we would get some weird error, would be that if our initial client was still connected after 65,000 other people connected and disconnected. Then it would go back and it would try and overwrite itself, and it would just be weird. So we're going to change that later, but for now that's fine. You're probably not going to get 65,000 people connecting, disconnecting while the first guy's there. It just won't happen. So let's go ahead and continue. The next thing we're going to have to do is create what's called a client map. And this client map, which is going to be a DS map, will hold all of our clients' objects into this map, so we can call them whenever we'd like. So I'm going to say client map. I'm going to do question mark, and we're going to have to convert it to a string. Make sure you convert it to a string, or it will not work. Equals our instance. So pretty simple. We just added that to our map using the object we just created with the socket ID. All right. So now let's go ahead and disconnect it real quick. And here we're going to just need the argument. So var socket ID equals argument 0. And here we can just destroy it. So if with client map string socket ID did I do that right? I believe I did. Oh. There we go. Alright. So with the client map, we're just going to instance destroy it. So we're going to just destroy that object. And we're just going to say ds map delete. And that's going to be client map and our socket ID. And actually you want to convert that to a string, socket underscore ID. Now this is just the server disconnecting portion of it. This is not anywhere the clients or anything like that. So we'll have to get into that later when we start creating the clients. Alright, so here's our disconnect functions. We've got our connect functions. Everything's cool. Now we need to go ahead and start with the hard part, which is our handling messages. So here we just put in our socket ID, argument 0, and our buffer, which is argument 1. Alright, so normally this will differ from any other game, whether you have a zombie game where you're shooting people or whether you have a platformer game. This is all dependent on what your game is, and it's going to be completely different in the long run if your game is anywhere unique. So the way we're going to do this is we're going to create a while loop that's going to loop through this, and remember now this only gets called every time data is being sent through the server. So what I'm going to do is create a message ID, which is basically saying, okay, if the player's moving, then I want to put that into its own case method of, okay, the object's moving. Or if the object is shooting, I want to put that into its own message ID, case shooting, that it's shooting. So the server always knows what's going on, whether, again, be moving, whether it be shooting, whether it be reloading, whether it be aiming, anything in your game really, we're going to be sending through these message IDs. So here I'm going to say while true, and here I'm going to say var message ID equals, and we're going to read this as a buffer. So buffer read, and here I'm going to say buffer, and I'm going to say buffer underscore U8. So again, this is the server, so we're going to be reading and writing a lot of things. So the server, like in our paint, the first thing it does if a client says something is it reads what's going on. So the first thing we're going to do is read, are you moving, are you shooting, etc. That's the first thing we're doing. And then we're going to read if let's say for example the message ID was move, then we're going to read what's your X and what's your new Y, right? Once it reads all of this, then we're going to have to write it back out to all the other clients, updating them on what the new X and Y coordinates are of our client. We're using a buffer U8 because if we go ahead and just look at it, buffer U8 stands for an unsigned 8-bit integer, so it's a positive value from 0 to 255, so it cannot go negative, and if it overseeds this value, then we're going to get some weird stuff going on. Here, you could do assign, which is negative 128 to 127, but normally in multiplayer situations, you never want to actually do that because you're now cutting in half your numbers on the right side. So always less data is good to send through because it's just faster. So if we use U16, unsigned 16, that's a 0 to 65,000. So you can kind of see the difference on how many things it needs to go through and how much data is being sent. So you always want to use the lesser number. Alright. There's things like bool and string and text, and that's like sending true and false statements, sending string values like in a chat message, all of that stuff. Alright, so this is just kind of knowing what's going on with that. Alright, so let's go ahead and create a switch statement called message underscore ID. And in this case, I want to make something for our moving. So I'm going to go into my macros, and in our configuration, I'm going to create a constant called message underscore move with a value of 1. And this is what we're going to be sending. So it's just under our constants, it's disguised, but we're really, every time we send a message ID, we're either just sending like the value of 1, the value of 2, the value of 3, and all of these have different cases for what they're actually doing. So I'm going to say case message move. We're going to break it. Now that we are in the message move and we've read that, okay, we are moving, now we can just exclusively send data that we're moving. So I'm going to create a variable XX, and this is going to be buffer read from our buffer, and I'm going to say buffer underscore U16 because our room is going to be bigger than 255. Our YY is going to be buffer read buffer underscore U16. Alright. So now that we've gained all of what we're doing, we now need to send it back. We need to send it out for everybody. So I'm going to say buffer write, and we're going to write down our buffer, which is actually what we need to do now because we need to create a new buffer that we can write on that's always going to be we can make one main buffer that will send all of the data no matter what it is. It can be through a chat system, it can be through this, through that. We can use one main buffer type to send everything. Right? So if we go to our server create and we say send buffer equals buffer create, and we'll put it the size of 256, and we'll say buffer fixed, which I'll show you in a minute, and with the alignment of 1. So our buffer fixed, there's all sorts of different buffer types. We've got buffer fixed, which is just a fixed size, which we just set as 256. We have buffer grow, a buffer that will grow dynamically as data is added, a buffer wrap, which just wraps it from the end to the beginning, and a buffer fast, which is just used for extremely fast data to read and write to. Alright. Now this sounds silly, but I actually forgot, I was getting a little bit ahead of myself. I forgot to actually add the client map as an actual DS map. So just a real quick thought right there. Create your client map in the server create as a DS map, and then we can actually use it down here. I apologize for that, but we need to actually create it before we can start doing stuff with it. Alright. So You can go ahead and read through these. We're going to be using buffer fix just because that's exactly what we need. And I put the size for 256 just because it's a number out there that we're really not going to exceed in bytes. 256 is pretty large. Well, it's not extremely large, but it'll do the job for exactly what we want to do. All right. So here we're going to write out our buffer, and we're going to use our send buffer. And our type is going to be buffer underscore U8. And we're going to send our message move. So here's what we're doing right now. Just so you're not copying the code, that's exactly what I don't want you guys to do when watching this series. I don't want you to be copying the code. I want you to be understanding it. So let's go ahead and go into Notepad. And here's what we need to do. We are going to, now that the server has received our X and Y values and our message ID, so that's the first thing it gets read. It reads our message ID, and then based on the message ID, it'll either read the X and Y or the shooting position or whatever, but since we only have our move, it's going to read the X and Y. Then it's going to write out everything to all the other clients. So first off, it needs to write the message ID that is being broadcasted to everybody. It needs to write out the client ID, so we need to know which client sent this message. So for one, we don't send it back to them, and for two, on every other client's computers, they know which object to move, which OServer client object to move. All right, then we need to send the X and the Y variables, and we are done. So that's what we're doing now. So the next thing we need to do is send our client ID, which we're just going to create it up here as a temporary variable. We're going to say client ID, and we got to name it current, because if we name it just client ID, it's going to get confused with our server create. Where is it? Our instance client ID there. So I'm just going to name it current, but it's essentially the same thing. And we're going to access the client map. We're going to say string socket ID dot client ID. So this client map is essentially just taking the instance of our client ID, and then we are going to write it. So buffer write send buffer, and here we're going to say buffer U16 and client ID current, because remember that our client ID can be anywhere from 0 to 65,000. So we're going to need our 2 bytes here, because this goes from 0 to 65,535. Now we can write our X, so buffer write send buffer, and this will be U16 again, and this will be XX, what we just read from, and buffer write send buffer, buffer U16 and YY. Alright, and then now that we've created this and we've read and we've written, now we just need to access all of the other server clients. So we can do that by saying with OServer client, and we want to make sure that we don't send data that we just posted to ourselves. So we're going to say if client underscore ID does not equal client underscore ID for server current. Whoops. Then we're just going to say network send raw, and we're going to say socket underscore ID, our send buffer, and the size. Now the size, as you can see here, we can look at it. So we're sending, we're sending the message move, we're sending our client ID, our X, and our Y. So this would be 7 bytes that we're sending. And so you can kind of just look at it like our U8 is 1 byte, U16s are 2 bytes. If we go and look, our U32s are 3 bytes, and our U64s are 4 bytes each. So if we do our X and Y, which are 2 bytes each, that's 4. Our client ID, that's another 2. So we have 6, and then our U8 is 7. So we're setting the size of 7. We're setting 7 bytes. One thing that we need to know about sending and writing buffers is that it keeps writing anywhere it left off. So if we didn't basically say, all right, we want to start back from the beginning, because if not, we would run through that 256 bytes like nothing. Then we can say, before all of it, buffer seek, send buffer, and we'll say buffer seek start, and offset is 0. So this is just gonna, every time we start writing, it's gonna bring it back to the beginning. Just as sort of like another fail-safe, let's say for example we do exceed the 256 bytes, we need to not send that data and just break it off completely, or else we're going to get a crashed game. So I'm going to say if buffer tell buffer equals buffer underscore get underscore size, or buffer, then break. And if we go and look at that, we can see that when you read or write data to a buffer using the buffer read or buffer write, the current seek position is advanced by the bytes written or read. And with this function, you can get the current seek position for use in other buffer functions. So we're just kind of just seeing where it's at, how much data we're using, and then this function just gets the size of the given buffer in bytes. So it's just sort of like a fail-safe. I would put that in there, of course. All right. So with all of that, we now have a server to run with our game. So that's going to be it for this tutorial. Go and like, go and subscribe. Let's go ahead and try for 100 likes this time. And if you didn't understand anything, please rewatch the video. And I look forward to seeing you guys tomorrow with the next video. Peace.